Look at almost any laptop charger cable. Somewhere along the cable, usually near one of the ends, there is a small cylindrical lump. Not a connector, not a plug, just a lump. It looks like the kind of part that should not exist, like reinforcement or leftover shielding or a cheap fix nobody bothered to hide. But that is not what it is. That cylinder has a name, a very specific job, and a reason it sits exactly where it does. Because that lump is there to solve a problem the cable itself helps create. The easy assumption is that a charger cable is just a quiet pipe. Power goes in, power comes out, end of story. But a laptop charger is not sending out perfectly calm electricity. Inside the charger brick, power is being switched and converted at very high speeds. And when electricity switches rapidly like that, it creates high-frequency electrical noise along with the useful power. That matters because a cable does not just carry electricity. It also creates an electromagnetic field around itself. And once high-frequency noise gets onto that cable, the cable can start behaving like an accidental antenna. Not a strong one, not on purpose, but enough to radiate electromagnetic interference into the space around it. That interference is not just theoretical. It can bleed into nearby audio equipment. It can affect other electronics. It can contribute to wireless noise. And if a device emits too much of it, it can even create compliance problems, because electronics are only allowed to leak so much electromagnetic noise into the world around them. So that strange cylinder is not primarily there to protect your laptop. It is there to protect everything else from your laptop charger. And that is the part most people get backwards. That lump is usually a ferrite bead, sometimes called a ferrite choke. Inside is a piece of ferrite, a dense ceramic-like magnetic material wrapped around the cable. And what makes it useful is that it does not treat every frequency the same way. At the normal power frequencies the charger needs, it has very little effect. But at higher frequencies, the unwanted noise created as a byproduct of switching power, it resists that energy and helps dissipate it as heat. Not enough heat to notice, but enough to make the noise much harder to travel along the cable and much harder for the cable to radiate into the room. So the lump is basically a passive filter. No power, no software, no moving parts. Just a material placed in exactly the right spot to make high-frequency noise harder to escape. That explains what it does, but it does not fully explain why it is so often visible on the cable itself. Because if this part matters, the obvious question is why not just hide it inside the charger and make the product look cleaner? Sometimes manufacturers do add filtering inside the charger, but the cable is part of the problem. Noise can travel onto it, along it, and off it. So placing ferrite directly around the cable is a very practical way to suppress interference right where that path exists. And from a design and manufacturing perspective, it is also flexible. If a product is close to failing an emissions test, adding ferrite to the cable can be a fast, targeted fix without redesigning the whole power supply. Which is why the solution can look slightly awkward. It is not there to look elegant. It is there because invisible electrical problems do not care whether the outside looks elegant. So that strange cylindrical lump is not a manufacturing artifact. It is not reinforcement, it is not decorative shielding, and it is not some random leftover part. It is a visible patch for an invisible problem. Proof that modern electronics are not just designed to deliver power, they are also designed to contain the noise they create while doing it. What looks like a clumsy extra part is often the simplest, cheapest, most effective way to stop a cable from becoming a source of interference. So the next time you see that little cylinder on a charger cable, you are not looking at useless plastic. You are looking at electromagnetic noise control made visible. If you want more small things with big reasons, subscribe.